Good afternoon. My name is George Finelli. I'm the Director of Aeronautics Research here at Langley. And it's my pleasure to introduce the colloquium speaker today, Mr. Joe Chambers. Joe's been at the center. He had a career, excuse me, let me start over. Joe retired from Langley in 1998 after 36 years of service here at the center. He's done a little bit of everything in his career that you could do out here, from modeling to wind tunnel physical ground testing to flight testing. He began his career in flight dynamics research at the Langley full-scale tunnel, which used to be on the Air Force side. In '74, he became the head of the full-scale tunnel, the Langley 20-foot spin tunnel, and other outdoor and free flight facilities here at Langley. In 1989, he became the head of aircraft flight research here at Langley. So yet another area of the kind of work we do here at Langley. And then in 1994, when there was a pretty big reorganization here at the center, he became the head of system analysis here at the center. So again, seeing the breadth of responsibilities he's had here at the center over his career. He has numerous awards over his career, including Outstanding Leadership Medal, Exceptional Service Medal, and Public Service Medal. He also received the coveted Arthur Fleming Award sponsored by the Washington D.C. JCs in 1975 as one of the 10 most outstanding civil servants for his management of the NASA stall spin research for military and civil aircraft. I've actually worked alongside Joe in one of the organizations out here after the reorganization in '94, and that was a pleasure I had in my career. And to know Joe is not just to know someone who, if you know, he's given other talks. He's actually given talks about the history of the full-scale tunnel and various other topics, recently flight research here at the center. But so as I've already said, if you know Joe, you don't just know somebody that knows about the history of Langley. He is part of the history of Langley. So it's my pleasure to introduce to you Joe Chambers.
Thank you, George. That was great. Haven't had that much fun since we threw spitballs at each other in meetings. I want to thank the Colloquium Committee for inviting me out to speak, and I'm really happy to see so many young people here because it's important to pass these legacy stories back to the younger people to carry on into the future. About a year ago, my wife had suggested that I look over my ever-growing collection of historical material at home. Actually, she didn't suggest it. She commanded that I do it. And cull out material that had already been published and clear out the house a little bit. And as I went through the stack, I ran across a yellowed manila folder that was labeled NASA insignia. That folder had been put there by my son Mark, who's here today, 21 years ago. Mark at the time was a law student working for the External Affairs Office here at Langley, and in 1992 the so-called Meatball came back into vogue, and Gary Price, who headed the office, realized that we had no story of how that emblem came to pass. So he sicked Mark on the story, and Mark, bless his soul, was in position to interview several key people before they passed away. But when I looked over the material that Mark had collected, it's obvious there was a long path yet to be told about the history of these insignia and how they came to be. And when I looked into it, I was absolutely surprised and shocked at events that happened relative to these two symbols that I was totally unaware of, and even more surprised that the NASA retirees didn't know that they had happened as well. So I think you'll find this talk interesting, and the fact that after 55 years, NASA has still not documented the total history of these two symbols. The two symbols you see, the NASA seal is on the left. It is a very formal, not used very often. It's For example, on the flag at your right on the stage, but you don't see it displayed too much except at formal events. The one on the right was a derivative of the seal, now known as the Meatball, but in its initial days was called the NASA insignia and is used for much less formal events, everything from basketball uniforms to license plates on cars these days. Acknowledgments right off the bat in doing this homework. My son Mark, I've mentioned. I've spoken to an awful lot of retirees at Langley, Ames, Glenn, and Johnson over the last year relative to these insignia. And the historical archivist at those centers and headquarters has helped considerably in identifying what is very, very limited information in the past. My biggest source of information, believe it or not, was the Army Institute of Heraldry. And I'll be saying more about what their mission in life is, but they had almost week by week diaries of what was happening while NASA was evolving its insignia. And the National Archives, which had a very limited amount of information for me. We see the Meatball every day. You come to work and you see this thing here at Langley, everything from our clothes and T-shirts to aircraft, speakers' rostrums, what have you. And people begin to ask themselves, how did this thing happen? Who was the designer? How did it come to be? And probably the most pertinent question to ask is, what is that red slash in the insignia? It has been referred to erroneously as an artist signature, as a vector, as a hypersonic wing, and the latest was a map of the runways at Area 51. So nobody's got that right, but when you finish this lecture today, you'll know what the answer is. This is an outline of what I'm going to try and cover for us. When word got around about this lecture, several people and some people at headquarters asked that I say a few words about the logos from the National Advisory Committee for Aeronautics, NASA's predecessor. The next step we're going to go through in a considerable amount of discussion is this so-called red slash or red wing, which I think you'll find very interesting. I'm going to cover the inter-center competition that evolved the insignia and the approval process, which resulted in a very embarrassing event in NASA's history, which you'll find amusing. We'll talk about the so-called worm, which was a love it or hate it activity within the agency, the return of the Meatball, and then I'm going to talk about a new modified Meatball called the Swoosh, which shows up on NASA's aircraft fleet, not only at Langley, but other centers as well. Let me start with the NACA story. I just have a few charts I wanted to show relative to insignia used by that agency. At the lower left here is the original laboratory located on the Air Force side of the base in 1920. It still exists today. It's been taken over by the Air Force as a conference center. But it still, as you can see, the entranceway looks pretty much the same as it did back in 1920. I've enlarged the area above the entrance door, and you can see the words Research Laboratory. And you can see this nondescript NACA circular symbol with a couple of wings on either side. That was the first attempt at some type of insignia to relate the NACA and its mission. However, the first real happenings began over in the flight area. The early flight test aircraft showed this shield, NACA shield, on the vertical tail of the aircraft, typically with a number like 82 to indicate that it was number 2 in the NACA fleet. And two pictures here. One shows a 1932 Boeing biplane, and the other was, this was the second Bell X-1 out at Muroc. This was the airplane devoted to the NACA's test program, not the Chuck Yeager and the Air Force program. But you can see it's still flying the shield on its vertical tail. So that was the first attempt to have some emblem relative to the NACA. The next event that happened was in 1941. It was established that there would be what was called a standard NACA wings, which was a combination of the shield with wings on either side. And after 1941, there was a so-called modification option, which is shown off to the right, which was a yellow or gold with NACA words written on it. This standard wing was relegated to all new facilities, wind tunnels especially. And this showed the 8-foot transonic pressure tunnel, Dick Wickham's wind tunnel over in the east area before it was demolished. Those wings show up today at the 16-foot transonic tunnel, for example. If you pass by there on your way to the cafeteria, you can see them there. And in the east side, there's a building. It's the first building you come to when you drive from the west area to the east area, which was the old NACA Flight Research Hangar. It also has the NACA wings on it. So a number of these still exist. The modified wings were typically used on aircraft, shown here. And the standard wings are those that were put on the highly regarded NACA wing retirement plaques, which people that work for the NACA were able to obtain at their retirement. Now a little audience participation. This was a surprise to me when I did the research on the seal that was developed for the NACA. This was the formal seal showing the Wright brothers' first flight. It was designed basically by the Army, the Quartermaster General's Office, and the Heraldic branch. Now, NACA was formed in 1915, and I challenge you to tell me which president approved this seal and when? Anybody have a guess? I was surprised to find out President Eisenhower was the one who approved this seal in 1953. It took a long time for the NACA to develop a seal. And by the way, President Eisenhower has the distinction of approving the seal for both the NACA and NASA, which is a fact that you can repeat at your next party. Now, as we got out of the NACA and time for NASA to enter in 1958, some strange, confusing things happened. This is a very rare picture of the prototype of the F-86D Sabrejet from North America here at Langley for flight testing. This picture was taken in October of 1958 when we had just changed over to NASA. They managed to paint the word NASA on the side of the aircraft, but as you can see here, they took the old NACA wing emblem and just put an S where the C was. So there was some confusion about what will NASA use for its emblem on its aircraft. So it was time for a change, and we'll get into the crux of the reason why we're here today, which is the NASA emblems. This gentleman, James Motorelli, is the hero of the day. He was the person who designed both of the seal and the insignia. He was head of the Research Reports Division at the NACA Lewis Flight Propulsion Laboratory in 1958, before NASA came into being. He was also in charge of the graphics department at Lewis. In 1958, in July, he took a trip out to the NACA Ames laboratory. And at the laboratory, they were in the middle of what was a 3-year rotation of what was called inspections, where VIPs were invited in to hear the latest accomplishments by the research staff. In 1958, it was Ames' turn in the barrel to tell their stories. And he made a stop at the high-speed aerodynamics display. This is a typical NACA Spartan, no frills, no PowerPoint chart stop. And a discussion here of the advantages and challenges in high-speed aerodynamics. When Motorelli saw this display, he was intrigued by this thing he saw over to the right, this model on the pedestal. And in his mind, this is an advanced symbol of aeronautics. This is really neat. I'll file that away for some future use. At the stop, a fellow by the name of Elliot Katzen gave a presentation on high-speed aerodynamics and discussed the research program that was underway at Ames, trying to continue to develop the efficiency of these types of shapes for high-speed flight. Katzon's mentor was the noted R.T. Jones, who was one of the most famous aerodynamicists and researchers to ever work for the NACA and NASA. He was an interesting person. He had no college education. He went to the University of Missouri for 1 year, was intrigued by flying, and joined a flying circus, and then a small aircraft company which promptly went bankrupt during the Depression. During that Depression, he was hired by Langley under the work program, came to Langley, became an expert on stability and control, the most complicated subjects at the time. He independently conceived the advantages of swept wings, and that's what he's doing here at the blackboard. He theoretically showed that there was an advantage for sweeping wings back for reduced drag at high speeds. His concept was ill-received by most of the aerodynamicists at Langley. They thought it was black magic and didn't believe what he had to say. It was, however, proven in one of the supersonic tunnels at Langley later in that year, and he went on for becoming famous in that activity. Jones transferred to Ames in 1946, and some of the things that he got involved in, he's the father of what's called the oblique wing, which is being able to have a variable sweep on an airplane in which the entire wing panel pivots about a single point rather than each wing panel pivoting. And you've probably seen some of this in the literature and some of the flight tests that have been done using that concept. He became a professor at Stanford, and he was quite involved in non-aerospace activities in his later years, everything from the design of telescopes to the design of violins. He was quite a fellow in terms of his impact on the program out at Ames. His concept, aerodynamically, was a so-called arrow wing. And basically, Jones rationalized this in terms of an efficient supersonic airplane. This shows a sketch, overly simplified, of an arrow wing flying at a Mach number of 3. And his rationalization was, at a Mach number of 3, the Mach cone shed from the nose would look something like this at that angle. And if you had enough sweep on the wing, the leading edge of that wing would be subject to a component, as shown here, which would be subsonic. So the wing could take advantage of subsonic airfoil sections to increase its efficiency at supersonic speeds. In fact, some of his first tests were done with a 1920 vintage Clark Y airfoil. So this was a concept that he pursued, and it was taken up by Ames in terms of their activities. The people at Langley, of course, were aware of this. They had some activity going on as well. Well, I tell you, it's tough to do this slide changer. This was a summary of activities that was going on at the two centers. At Ames, the optimization of the arrow wing aerodynamics. At Langley, we were doing theoretical studies of arrow wings and applications of the arrow wing to actual airplane configurations. And it was well that we were doing that because something happened in this time frame, 1957. We know what Sputnik, what that was all about. The height of the Cold War, we were very concerned about the susceptibility of the U-2 spy plane for shoot-downs, and of course that happened a few years later. That started the program for the A-12 to become the SR-71 spy plane in this time frame. But there was another major project the Air Force wanted called Weapons Systems 110A. That project called for an intercontinental nuclear bomber capable of 6,700-mile range, fly unrefueled to the Soviet Union. Initially, they considered a nuclear-powered aircraft. That went on for a year or so, and then they went back to traditional chemical fuels. The project ran into big trouble. They had contracted Boeing and North American to design such a bomber. The project was close to cancellation because of what they came up with. This was the North American proposal for that mission. It used what's called a free-floating wingtip concept. It carried fuel in the outer wing bodies, and the wing was hinged at this point to relieve structural loads on the wing during flight. It was a concept that was quite popular in the 50s and involved a couple of in-flight accidents during different types of experiments using the concept. But the airplane would fly out with these fuel tanks on the wingtip, drop them as it approached the target area. This would be a subsonic cruise out, and then it would have a supersonic dash capability of Mach 3 over the target and bomb the target at 60,000 feet. The airplane, in its full takeoff gross weight, weighed 750,000 pounds, which is roughly twice a B-52, twice the B-36, and much more than any runway in the world could tolerate. The Air Force looked at the cockpit and the canard in front of it, wondering how the pilot was ever going to see the runway for takeoff and landing. And the famous and very profane General Curtis LeMay, who was head of the Strategic Air Command, took a look at this design and said, hell, that's not an airplane, that's a formation of 3 airplanes. Go back to the drawing board. And this program was in deep, deep trouble. Floyd Thompson, who was the associate director at Langley at the time, formed a high-level, top-secret team here at Langley to support this activity and show what might happen if they took advantage of advanced technologies. One of the interest areas was the Arrow Wing, and he assigned the leadership of that program to this person, Clint Brown, again, one of the most outstanding people that ever worked here at Langley. Clint began his career here at Langley in supersonic aerodynamics, and he was involved in a number of important activities. He was a participant in 1942 jet studies. People don't realize that this center actually did some early work on jet propulsion back in the 42 time frame. He was involved in that first tunnel test that verified the effect of sweep that I talked about earlier. And also in 45, NACA did ramjet studies that people don't know much about. He led the study group for the X-15. He was a leader in orbital mechanics and space flight, and he headed Langley's Lunar Mission Steering Group. But at this time in his career, he was given charge of this Arrow Wing activity and told to generate an activity that would show the value of it. Clint joined forces with Ed McLean. Ed went on to become famous in NASA's early work on supersonic transports. And the two together designed this wing, which you might think looks very familiar to a red slash on the NASA insignia. You can see the twist and the camber. The nose of the wing, you can see, has an upturn, cobra-like front to it. You can see the trailing edge is bent down, and you can see the camber that's in that wing as well. This was referred to as the Brown Bomber, and it had undergone wind tunnel tests here at Langley in several facilities, and it was compared with other competing advanced aircraft designs. This shows a picture of the airplane as a bomber, not just the wing, but the rest of the airplane. The twin vertical tails, a 6-engine pack. It was also tested with a centerline engine pack underneath it. And over here you can see that cobra-like nose that was involved on the wing of the aircraft as well. Now the results of that test were stacked up against 3 other advanced designs. This was the Arrow Wing, Clint Brown's airplane. This so-called outboard tail configuration, which was Tommy Toll, another leader here at Langley in those days. This was the favorite of North American, a clipped Delta canard. Owen Morris led that activity in the unitary tunnel, and Dick Wickham got in on this game with the design of this Delta Wing configuration. North American was interested in this clipped Delta because it took advantage of a concept developed by Eggers and Syverson from Ames called compressive lift. And basically the name of the game was to put an engine inlet under the wing and have the compression shock act on the lower wing to provide additional lift without significant drag increase. And you could gain something on the order of 30% lift-to-drag ratio by putting an airplane together like that. So North American went into this study wanting that airplane right off the bat. But let's take a look at some of the results that came out of the study. This is a measure of the supersonic efficiency, lift to drag ratio, the maximum value versus Mach number. And you see the arrow wing of Clint Brown, Dick Whitcomb's delta wing, the canard configuration, and the outboard tail. All of them at a Mach number of 3 came in around an L over D max of 6. These were wind tunnel values, and when extrapolated up to full scale, got them up to about a maximum value of 7. So on the basis of this, the fact that the canard configuration was acceptable, and when the industry looked at this airplane, it was going to involve a lot of development work, the decision was made to go with this configuration. This was what ultimately the WS-110A project turned out to be, the XB-70. And you can see the similarity to what was tested in the Langley tunnels with a canard type configuration. What did we learn from this arrow wing that ends up on the NASA emblem? It didn't pay off for that program, but very, very importantly, it supplied the fundamental information and data design methodology that was used by NASA and industry in follow-on activities involving civil supersonic transports. When computers became the vogue and higher order techniques could be used for the wing design, people like Roy Harris, who led the supersonic design work at Langley, were able to come up with airplanes like the Scat-15, which exhibited an L over D of no less than 9.6 projected at a Mach number of 2.6. It was really a refinement and based on that earlier work on the arrow wing. So it wasn't all for naught. We did get quite a bit of feedback on that. Okay, I've told you all about red wings. I've told you what you should know now about what you see in the NASA insignia. It leaves the question, okay, whose wing is that? Was it the wing out at Ames or was it the wing at Langley? In my opinion, based on what I've researched, I think that Jim Mortarelli visited both places. We know he did. And when he came to Langley and saw what Clint Brown was up to, I'm convinced that he used that wing as his model for the insignia. Now, let me go back to the story. I had to digress a minute to tell you that story, but let's go back to how the seal developed. I apologize for this slide, but this is the best single sketch I could find of the candidates that were submitted to headquarters when they invited the centers and headquarters staff to submit designs for the insignia for NASA. Over 350 different designs were submitted. After they were all submitted, they sat around with NASA's first administrator, Keith Glennon, and spent half a day arguing about the merits of all 350. And finally, Glennon got up, pounded the damn table, and said, I'm going to make the decision. We're going with this one. So he picked the one that was submitted by the Lewis crew, and furthermore assigned Jim Mortarelli to lead the efforts to develop that seal, but also a less formal insignia that could be used for other general purposes. This is what they had to go to get this thing approved. The seal required a very concrete format of going through the Army Quartermaster Corps for checkout of the graphic, and then they had to go through the Commission of Fine Arts in Washington, which I'll say more about in a minute, to get it approved before it could finally be approved by the President, Eisenhower in this case, shown with Dr. Dryden and with Glennon, the first administrator. On the other hand, the simplified insignia did not have to go through that process and could be approved by Keith Glennon himself. The Army Institute of Heraldry exists today. It provides services to the Office of the President, all government agencies, the military, since 1919. If you're going to design a seal for your agency, you have to go through this group. They make all of the plaster symbols and seals that you see decorating different halls or rooms, conference rooms in different locations. And when the President speaks, if you look on the wall behind him, they also had a hand in doing that work. The Commission of the Fine Arts was established in 1910. It has the authority to review the design of anything, medals, insignia, statues, monuments, which in any way affect the appearance of Washington, D.C. That's a pretty big responsibility. And that led to one of the first clashes between the arts community and the scientific community within NASA. Now, a story. I'm going to pause and tell you, I interviewed a person by the name of Jack Crenshaw, who retired from Langley years ago. He worked for Clint Brown, and before I called him, I had just got in a package from the Army that showed me something that just about floored me. I could not believe that NASA would make a mistake like this, but I talked to Jack, and Jack says, yeah, I worked for Clint, and let me tell you a couple of stories. Number one, I went into his office, and he had this red wing model on his filing cabinet, and I asked what it was, and he said, oh, it was a design for a supersonic bomber that I did a few years ago. And Jack said, how did it work? And he said, well, not worth a damn. So he came back a few days later, and the wing was gone. And, okay, Clint, what happened to your wing? He said, oh, the photographers came by and picked it up. This new agency's looking for something to use in their symbols, and they decided they wanted to take some pictures of my wing. He said about 4 or 5 weeks later, he heard Clint Brown laughing and laughing and laughing. He came into the office, and what are you laughing at? Clint says, well, they've just notified the centers as to what they picked for the NASA insignia, and they've got my wing in it, but they drew the damn thing upside down. This was actually the wing that NASA submitted to the Army and to the Commission of Fine Arts. What happened was the photographers had taken a picture of that model mounted upside down in the wind tunnel and passed it on to the graphics people, and of course they did their job. They just decided to draw it as they saw it. And you can see the trailing edges are bent the wrong way and the nose is bent the wrong way, etc. So needless to say, when headquarters found out that a mistake had happened, they called the Army and said, stop everything. We don't want that seal. We're going to give you the right design. So you can see, comparing this with today's design, the wing was redrawn in an upright position. It was also tilted over to give a more edgewise view of the wing. The shadow on the Earth and the other planet were redone. In fact, this time they did it right. They actually took a photograph of a model mounted above a sphere so they could get all the shadows right. And the Army wanted all of the lettering to be the same, and there were some changes made in the stores. But in any event, the stopper was quickly put on what was going on in the Army. The insignia was approved by Lenin in 1959. President Eisenhower signed and put it into, established it. It was amended by President Kennedy in 1961 to change the color of the shadow on the planet, no big deal. And of course, it played a role in all of the arguably good days that NASA had in the early days. Mercury, Apollo, Viking, all of the excitement, all of the pride went into that insignia, and it was beloved by all, but not all. It had its foes and critics. The Commission of the Fine Arts, when they approved the insignia for NASA, said the design was reluctantly approved. This thing has limited sculptural possibilities. So here was the arts community fighting with the bound-in NASA researchers saying, no, we don't like it, but we'll approve it anyway. Time magazine came through with a scathing article in 1961 after Alan Shepard's flight, saying that the medal that was given to Shepard looked like something that came out of a Cracker Jack box. Certainly NASA can make a better symbol than that. Again, this was from an artistic person from the graphics world. There was one problem with the insignia, though, and that was printing difficulties. The blue colors that were used in it were very difficult to reproduce on printers at the time. All of this built up to the point where in 1975, President Nixon initiated the Federal Graphic Improvement Program, which was to take all agencies and, quote, improve their insignia or logos. This was designed, the so-called worm, was designed by a contractor, not by NASA. And it was accepted with resistance by then the administrators, Fletcher and Lowe, who said, something looks strange about this. We're not sure we're happy with it, but nonetheless it was accepted as a new logo. this developed into a real love it or hate it faction standoff between the existing NASA community and the artistic community. When Dan Golden became the new administrator, he held many, many town meetings and asked, what can I do to improve the morale of NASA? And he heard this comment quite a bit, bring back the meatball, which he finally did. And when he did it, in 1992, he called a meeting later that year and awarded James Motorelli and his wife a special award to the creator of NASA's original meatball in honor of your lasting contributions to the proud spirit of the National Aeronautics and Space Administration. So Jim Motorelli got his due at the end of the activity. In 1997, after 30 years of hanging on the Lewis hangar, their meatball got pretty ragged, so they decided to replace it and invited the staff and retirees out to sign the back of this meatball before it was put up on the hangar. There were over 300 people that did that. The very first person to sign it was Jim Motorelli. 5 years later, Motorelli passed away, but he often said that that was his most pleasurable moment in life, was being the first in line to sign what would be his legacy. Now, I want to change subjects and talk about something that's happened fairly recently called the swoosh. In 1993, NASA found itself having to maintain and repaint its fleet of T-38 aircraft. There were over 30 of them at the time. And the worm had gone away. The question was what to put on these aircraft. And the people down at Houston did not want to convey that they were going to spend the manpower to paint meatballs on the tails of these airplanes. So the people at Ellington and at Johnson decided to put what they called the swoosh, which was a simplified version of the insignia. No offense to this famous sporting good clothing manufacturer, but they named it the swoosh. As you can see here, it looks pretty good on the left side. Personally, I think it kind of looks strange on the right side because it had to be facing the rear. Otherwise, the slash would come off the vertical tail. So that led to some strange looking aircraft from the right side. This is the NASA WB-57 high altitude research airplane. Now, Jim Motorelli, bless his soul, is probably thinking, what's going to happen in the future? All of you young people know what this is. When you ask, what would the meatball look like in the future? Anybody know what it is? Well, I am disappointed, guys. I am disappointed. Hollywood solved the problem. This is Star Trek's United Earth Starfleet insignia. If you go back and see some of the old movies, it was a patch worn on the right shoulder by the Starfleet personnel in the 2160s. So we're already out in the 2160 time frame. And you can see that they basically laid it out somewhat like the NASA meatball insignia. I've tried to lead you through the story of how these insignia came to be. I hope you leave here understanding what the red slash in the insignia is and have a better appreciation of that. I understand you youngsters are going to have to design your own insignia for your mission to Mars. Good luck. I hope you don't have to go through the Commission of the Arts in Washington. And that you draw whatever you come up with right side up, okay? That's all I have. I hope you enjoyed it as much as I did doing the research on it. I'll be glad to answer any questions.
If you ask a question, please go to one of the microphones so you can be heard by everybody.
Any questions? God, you guys are great. I hope I didn't put everybody to sleep. I hope you enjoyed it. Peter, you're going to, okay. Peter Cohen, leader of the supersonic program.
As I recall, when right after, come on, his name became administrator and bring back the meatball. Golden came down. Sorry.
You can forget that, Peter, huh?
He came down on us, he visited all the centers and was supposedly met on the ramp by Paul Holloway. And, you know, because we still had the meatball insignia, and he said, get rid of the worm and bring back the meatball, because that brings out the famous picture of Golden embracing the meatball on the 737 in the hangar. Right. Which was famous for other reasons.
Absolutely.
But we sat here, and that was to my recollection, is when he first said, we're going to get rid of the worm and bring back the meatball.
Correct. Yeah. I spoke to Paul the other day, by the way, and he remembered that when the airplane pulled up on the runway, Golden again asked him, what can I do to improve the morale of your center? Bring back the meatball. Yeah, he did. Yes, sir.
I was wondering, why is it called the meatball? Like,
Oh, I'm sorry, I missed that point in my story. It was always known as the insignia, okay, until the point where the so-called worm was brought up by the headquarters staff. They were the ones to first refer to it as a meatball. It was always the insignia. And meatball as a nickname has stuck with it since that time, but it was 1975. It went for 17, 18 years as the insignia.
So this will be cleaner. I do have a question, Joe. Your image of the space shuttle shows the Enterprise, what appears to be in the launch position. How is that possible?
I don't know. I picked it up. I can't answer your question.
It's your
Can't answer
next
your
talk.
question. Ask me a question about L over D, I can answer, but not about the shuttle. Any other questions? Yes, sir.
Hi, Joe. I just want to make a comment. I don't know how many of you have noticed when you come facing the badge and pass office, but the windows are designed in the shape of the NACA wing. So take a look when you go out to see.
Yes, ma'am.
I read recently that for the mission patches, that only the people in the crew know exactly what the meaning is behind each of the little things on the mission patches, and the designers. Is that true? Do you know?
To my knowledge, they've fairly well publicized mission patches in terms of the significance and what the symbols mean in the patches.
Okay.
Yeah. The crew obviously has a big say-so in what they want their patch to be, but once that decision was made, I think NASA's been fairly open about what the different symbols mean.
Hi, Joe. I was wondering, is there any significance to the number of stars involved in the insignia?
Not to my knowledge, no.
All right, one more comment. So I actually think that the folks that said it doesn't represent well in sculpture were right. Have you ever seen the sculpture at our reflecting pool out here? It just does not work.
Yeah, yeah. They were quite critical. The people in downtown D.C. were quite critical that this was a typical 2D type drawing, and it isn't going to bode well for any type of sculpturing or 3D effects.
Once upon a time, I seem to remember that podium had a NASA seal on it. Do you have any idea when that may have changed?
I'm sorry, I didn't hear you.
The podium that you're standing behind had a NASA seal on it at one time.
Don't know. I actually did quite a bit of homework for this presentation, trying to find a picture of Bolden or anybody with a picture of the seal on the podium, and I could not find any, even with him. I mean, today, the only thing I've got is the flag over there on the stage. Okay, folks, I've kept you long enough. It was a pleasure speaking to you. Thank you very much.
On behalf of the Colloquium Committee and the Langley Research Center, Joe, we wanted to give you a token of our appreciation for this great talk, one of the NASA Langley plaques. Thank you all for coming. Good afternoon. My name is George Finelli. I'm the Director of Aeronautics Research here at Langley. And it's my pleasure to introduce the colloquium speaker today, Mr. Joe Chambers. Joe's been at the center. He had a career, excuse me, let me start over. Joe retired from Langley in 1998 after 36 years of service here at the center. He's done a little bit of everything in his career that you could do out here, from modeling to wind tunnel physical ground testing to flight testing. He began his career in flight dynamics research at the Langley full-scale tunnel, which used to be on the Air Force side. In '74, he became the head of the full-scale tunnel, the Langley 20-foot spin tunnel, and other outdoor and recently flight research here at the center. But so as I've already said, if you know Joe, you don't just know somebody that knows about the history of Langley, he is part of the history of Langley. So it's my pleasure to introduce to you Joe Chambers.
Thank you, George. That was great. Haven't had that much fun since we threw spitballs at each other in meetings. I want to thank the Colloquium Committee for inviting me out to speak, and I'm really happy to see so many young people here because it's important to pass these legacy stories back to the younger people to carry on into the future. About a year ago, my wife had suggested that I look over my ever-growing collection of historical material at home. Actually, she didn't suggest it, she commanded that I do it, and cull out material that had already been published and clear out the house a little bit. And as I went through the stack, I ran across a yellowed manila folder that was labeled NASA insignia. That folder had been put there by my son Mark, who's here today, at formal events. The one on the right was a derivative of the seal, now known as the Meatball, but in its initial days was called the NASA insignia and is used for much less formal events, everything from basketball uniforms to license plates on cars these days. Acknowledgement right off the bat in doing this homework. My son Mark, I've mentioned. I've spoken to an awful lot of retirees at Langley, Ames, Glenn, and Johnson over the last year relative to these insignia. And the historical archivist at those centers and headquarters has helped considerably in identifying what is very, very limited information in the past. My biggest source of information, believe it or not, was the Army Institute of Heraldry. And I'll be saying more about what their mission in life is, but they had almost week by week diaries of what was happening while NASA was evolving its insignia. And the National Archives, which had a very limited amount of information for me. We see the Meatball every day. You come to work and you see this thing here at Langley, everything from our clothes and T-shirts to 21 years ago. Mark at the time was a law student working for the External Affairs Office here at Langley, and in 1992, the so-called Meatball came back into vogue, and Gary Price, who headed the office, realized that we had no story of how that emblem came to pass. So he sicked Mark on the story, and Mark, bless his soul, was in position to interview several key people before they passed away. But when I looked over the material that Mark had collected, it's obvious there was a long path yet to be told about the history of these insignia and how they came to be. And when I looked into it, I was absolutely surprised and shocked at events that happened relative to these two symbols that I was totally unaware of, and even more surprised that the NASA retirees didn't know that they had happened as well. So I think you'll find this talk interesting, and the fact that after 55 years, NASA has still not documented the total history of these two symbols. The two symbols you see, the NASA seal is on the left. It is a very formal, not used very often. It's, for example, on the flag at your right on the stage, but you don't see it displayed too much, except
free flight facilities here at Langley. In 1989, he became the head of aircraft flight research here at Langley. So yet another area of the kind of work we do here at Langley. And then in 1994, when there was a pretty big reorganization here at the center, he became the head of system analysis here at the center. So again, seeing the breadth of responsibilities he's had here at the center over his career. He has numerous awards over his career, including Outstanding Leadership Medal, Exceptional Service Medal, and Public Service Medal. He also received the coveted Arthur Fleming Award, sponsored by the Washington, D.C. JCs in 1975, as one of the 10 most outstanding civil servants for his management of the NASA stall spin research for military and civil aircraft. I've actually worked alongside Joe in one of the organizations out here after the reorganization in '94, and that was a pleasure I had in my career. And to know Joe is not just to know someone who, if you know, he's given other talks. He's actually given talks about the history of the full-scale tunnel and various other topics